Hello everyone, October 18th. Alright, we're very late today. I got hammered today. Hammered bad about the the dissertation stuff that we're working on. I mean, it's just trying to find the best way to handle the machine learning part. Like, how do we tune the parameters so that it give us the best result? And we might see the light at the end of the tunnel. We might, but not so sure at the moment. We'll keep digging tomorrow. I feel like this week is going to be very important. If this week we can see some very promising results, then it's going to be good. It's going to be good. And I think this week, next week, so including this week, I have another week and a half to really push the current project to the end, because I will have to collect new data for the next thing. I mean, I didn't really have enough data, honestly, for this current project. And I did collect data for 4 months. I mean, the previous semester, I won't say daily, but at least 2 or 3 times a week, I went to collect data, but I wasn't smart about the data collection. And, with all Wi-Fi and stuff, it turns out the antenna orientation, it matters, right? You have to twist the antenna, point in different directions in order to get a good overall shape of how the data look like. If you only point the antenna to one direction and then collect data that way, it can only predict when the antenna is pointing the exact same way. And man, my cat is just opening cabinet doors. All right. So let's just cut the crap right here. The goal, you see we have 2 open, so I want to write the solution 2 for this one again. We kind of did it yesterday, but we didn't do it very well, so I'm hiding it, so I'm going to do it again. And this one, oh my god. We need to child-proof our cabinet. Just for our cats. Alright, so I'm gonna do these 2, and this one is the base. Oh, so bad. So bad yesterday. So I'm gonna do these 2, and of course I'm gonna finish this one first. Alright, let's see. Top k frequent words, give an array and an integer k, return the k most frequent strings. I think does counter have a function directly for that, right? Yeah, I am using the easiest way to handle it. I think counter has the most common. Oh, most common. It might not give you. Actually, I'm not sure. So we have to take a look. Counter, chain map. I didn't click chain map. Well, I have elements. No, most common. And most common. Nah, that's not what we want. We don't have. That is fine. Yeah, it's fine. Alright, let's just do this. What if it doesn't exist? Return the answer sorted by the frequency from highest to lowest. Sort the words with the same frequency by their lexicographical order. Oh, no, the k most frequent. It is the k most frequent. The 2 most frequent. Oh, I can use count. Okay, I think what I'm going to do is Holy crap. So basically it's implement the counter. All right, how would you do it if you don't? Okay, we wouldn't do it two ways then. We'll do it two ways. We'll do one with counter and do another one. Do another one without. That's from yesterday. Yeah, we'll do one with and do one without. Counter. Do one with and do one without. Can we do this without in one line? Let's see, counter words dot most common k, right? Most common k. So we give you this. That is sort. In the order first encounter, no, we have to sort it. Holy crap. It's oh, okay. Okie dokie. That might not be the one that you want. Actually, no. This is actually making it a little bit more difficult, right? Because you have to sort it again. So why don't we just sort it, Yeah, we will sort first based on this and then based on this, right? So I just need the whole thing. You know what? I don't want to use this. I can. All I need to do is sort again. Yeah, then you have to sort both. Yeah, I don't like it. That's fine. That's fine. We can just say dot items. Maybe we can sort directly on this. What do you think? Yeah, I don't see why not. Maybe we can sort this and then key equals lambda. They call it tuple. We call it tuple. I'm not sure. We'll see. When the return, right? So it should be minus top 1 and top 0. So once we do this, we take the first k. If it's not right, then most likely the problem is with the sort. So we'll do this. I love. Four, right? Okay. What's okay? Top k frequent. Ew. That is ugly. That is ugly as hell. Damn. So I can't do that. All right. I mean, I can. My God. For W and underscore in this. Then we do W. Yeah, I'm hell banned to do in one line. In the edge case. O and log k time. and on extra space. Well, this one, let's submit this one first. All right, and then it's asking for on log k time. This is on log. This is on log n, because you're sorting the counter. On log k. So what are they asking about? On log k. 692. On log n with O n extra space, right? Yeah, add O n extra space. However, the requirement is to achieve on log k time. So this solution doesn't count. All right, let's see, on log k. Well, we need to counter it no matter what, right? We counter it, and it's asking for on log k. We counter it, we have words and the value, the count. Then we need to find the maximum. And if you use a heap, each is log n, right? So it'll be like k log n. So it'll be on k log n. On plus k log n. You do it k times. Oh, actually, no, you can't. You have to get all of them out. Top 4, the top k. The top k frequency. Yeah, it's actually, you have to get all of them out. On log k. If we saw the words as on log n again, I should have no idea. On log k. Alright, let's see. I have no idea. Hints? No hints. What's on log k? On log k. Hash map and priority queue. How is priority queue on log k though? Oh, priority queue with count. That's still not over log k. How is this log k? Oh, we keep only the top k. That's how you keep a log k. Oh, shoot. Yes, now I see. Log k. Oh yeah, the top. It should be a. Damn, this should be a. Yeah, it was a shame. What a shame, right? What a shame. Whenever the question is about the top or bottom k elements, always use a priority queue. All we need to do is to keep the size of the queue at k, right? Any addition, no, yeah, if new ones need to be added, we always pop the top. We always pop to keep the queue size at k. This is very important, and thus we do n an insertion, and each insert requires log k, right? It requires log k operation to reorganize. And since we want to keep, right? Since we want to keep the top k most frequent, the queue must be a min heap, right? This way, we always pop out the smallest. We always pop the smallest in the queue when a new element is added. Yeah, we just add. Next one add, we pop the smallest. Next one add, we pop the smallest. And once we all pop, it's just the top k. Okay, so first things first, it's still going to be a counter, right? This thing doesn't change. That's on. And then we say heap equals this, right? And then, oh, do we have a, actually I don't know. Let's see. Heap q. It's not heap. It's heap q. Heap q. Heap push a value, maintaining the heap invariant. It doesn't have a key. Heap.merge, n largest, n smallest. But I think I can put, yeah, I remember heap. You can put two things in it. Yes, that's fine. So we can say for key value in counter.items, right? So we're just gonna put it in, and it's a min heap. So we need to we have to also sort based on, so like when value is the same, then we're going to compare on this, and we want to sort lexicographically, right? And if it's a min heap, then what do we need to do? If it's a min heap, then the smallest count at the top. So the words need to be, holy crap, how do we do that? How do we reverse the words? You can't put negative in front of the word. And I cannot just simply put it in the tuple. Because if I put it in the tuple, oh man. I don't want to create a new object though. A heap. So I need a max heap. Max heap for the max heap for the letters, for the words. I mean, like A is larger than B. How would you make B larger than A? That's basically what it is. I actually don't know. Python max heap English words. How'd you do that? Max heap of strings. Yeah, that's the one. It's a very good question. Oh, come on. Come on. Yeah, no. No. I don't like it. I don't like it. Okay. So, yeah, I guess that's the way we have to go. Shoot. I don't like it. I don't like it at all. But I don't think there's another option, right? All right, let's do this. Class heap element. Well, I can call it node. So what we have word count, right? Self word equals word, self count equals count. Okay. Then we need to implement def. I think it's this other. I think this one returns boolean value. This one is a none. Okay. We say if self.count, right? It's gonna be the min heap, right? We say self count is smaller, is equal to other.count, and return self.word larger than other.word. So I think they call this, right? If it's smaller, they will push into the top. And then we want a large word to push to the top, which means if word is, then we push to the top. Otherwise, we'll return self.count smaller than other.count. Yes, so that's what I think a node will be. And then we just go this, and then we say if len heap. Now we're gonna first do heap q.heap push heap, and then node kmv, right? Kmv, and then we say if len heap is larger than k. Oh, we cannot use k. Cannot use k. Let's use word. I just feel word and count. That's easier. Node word count. If it's larger than k, then heap q.heap pop. Just pop it. And then when I return, oof, it's not sorted. It's just Oh, we can just pop. We can just pop. So return. Oh, yeah. Yeah, we can do this. We can do this. Let's say for this in range k, right? Then heap q dot heap pop heap. Right, we're gonna pop the heap. Oh, pop the heap is going to be the smallest. Dang it. So we have to reverse it. So we pop the heap, and all we want is dot word. So we do this and reverse it. Let's see if it works. Yep, it works. So this is kind of the thing. Yeah, we have to use this. Now, I don't think this will be faster though. All right, let's try this. That runs fast, but it's not the fastest. So this is on log k. So this is on. This is on log k here, on log k, and this is ok log k. So overall on log k. The runtime is pretty bad. I mean, it's a Python method. Let's see how they do it. Yeah, you have to use this, unfortunately. Yeah, there's nothing. Yeah, there's nothing you can do. Yeah. Smallest has key. Oh yes. Oh yeah. Oh. Wait, what? We put frequency in it. K smallest, and then we do word. Wait, hold on. K smallest. K smallest. I think we're doing a max heap here. we do a max heap. Can we do a max heap? No, but this is just to get the smallest. So what is the smallest? We inverse the count. This is actually pretty good. This is a pretty good idea. Yeah. 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 That's actually a pretty good idea. But I think the key, right? The key is to put the word in it. I think that's the key. And then use n smallest. Yeah, it works. Alright, so we spent a long time on this one already. So let's just turn it over to this one. Now I want to rewrite this. Class solution 3. Okay, this is exactly the same. So this is exactly the same as solution 2, but I want some more practice on this thing, on this problem. So what we're doing is we are saying, right, we use DPI to represent the minimum schedule difficulty on the kth day. What is the jth day? On the jth day, covering jobs from 0 to I. We use, actually we can say j minus 1 day, right? J minus 1. I like to say j minus 1 day. And then we use a temp I to represent the minimum schedule difficulty on the jth day, covering jobs from 0 to I. And the initial attempt at computing temp I shall equal to the previous day, I minus 1, right? The previous day plus job difficulty I. So this says if we group job I by itself, then temp I is equal to the by itself for today, for the jth day, then is equal to the sum of the main schedule difficulty of the previous day up to job j I minus 1 and the job difficulty of today, right? Then we need to explore the possibility of grouping job I with some of the previous jobs without incurring more difficulty, right? This means we want to search backwards to include all the jobs that have difficulties lower than job I. To facilitate this action, we use an additional monotonic decreasing array. the tail of decreasing stack. The tail of the stack is the smallest job difficulty that is larger than job I. Thus, everything in between can be grouped with job I for the jth day without increasing the overall difficulty of today. Right, so to update, so if the tail of the stack is smaller than job I, then we can group that job with job I. So we pop it, right? So we pop it from the stack and update temp I, right? Because I include that. So when you say temp, yeah, the current day, temp stack -1, right? That's that job. What's the minimum schedule for that? But then for me, it's gonna be that one minus job difficulty stack -1, then plus job difficulty I. Minimum of temp I and this thing. Once all the tail of stack is handled, we arrive at the end of stack that is the smallest job with higher difficulty than job I. We have a choice to make here. Either let that extend the end of stack to include job I, right? To include job I as one group of job, or not. This is expressed as temp I shall equal to the minimum of temp I and temp stack -1. So ND complexity. Okay, so we have to borrow a few things. We'll borrow this. Right, and then we say dp shall equal to math.inf times n, and then temp shall equal to 0 times n. Right. And then we say for j in range d, right? And then for the job, for I in range j towards n. These are the jobs. And we have to do this because if I am on the second day, right, then I cannot start from the first job because each day has to do at least one job. So now we have for I in this, then we need my stack. Okay, we need my stack is here. And then for we can do temp I, right, shall equal to dp I minus 1. Say if I larger than 0, else 0 plus, this one I have to do this, job difficulty I, right? And I say while stack and stack minus 1, if it's smaller or equal to smaller or equal to job difficulty I, right? It's actually have to go job difficulty this, right? If it's smaller than that, then j, not j still, we can say k. Can we say k? Yeah, we can say k equal to stack.pop, right? So this is something that's smaller than me, so I pop it as I include it in me. So we say temp I and equal to minimum, temp I, and then we say it's going to be temp k. So the minimum schedule up to that, right? And then, because up to that, we include k. So we do minus the job difficulty k, but plus job difficulty I. Right? And then we keep doing this, and then when we're done, we say if stack, then the end of the stack might extend towards me. So I say another possibility is this shall equal to minimum of temp I and temp stack minus 1. Once we've done this, then stack.append I. Right? Then we go back, we done all of them. Once we're done, we say dp temp equals temp and dp. Once we're done, we return dp minus 1. Because that's the last day and towards the end of the job. Now we run this. Oh, I always forgot about this. So if d is larger than n, then return minus 1. There we go. All right. Oh, let's try this. Yep, pretty fast. Okay, so that's that. All right, turn this off. Base 2. All right, let's see. What the hell is this base 2? Base minus 2. Two lines, exactly the same as base 2. All right, so I'm not gonna keep reading. I will just say, wait, how do you do base 2 though? How do you do base 2? All I think about is a log. Okay? All I think about is a log. But you can do divide. Yeah, what is base 2? What is this base thing? Base 10 is this 1. You divide it by 10 and you have the remainder. Then you take about the rest, you divide by 10. So the 2 is the same thing. My God, I forgot about the most basic. 7 divided by 2, right, is 1. So the last one is 1. Because it's 2 times something plus 1 equals 7, right? So now what? Because 2 times 3 plus 1, right? Now we need to do 3. And 3 divided by 2 is also 1. Now we got 1. 1 divided by 2 is 1. That's 1, 1, 1. Oh, I forgot a division. Yeah, you divide. And then that's the thing. And then into something times 2 plus 1, right? Because at the end of the day, it's going to be something like this thing times 2 plus this thing. This thing times 2, whatever this thing is, times 2, plus this thing times 2, plus this thing times 2. So we just need to say these things divided by minus 2. All right, what's 7 divided by minus 2? Div mod 7 and minus 2. Minus 4 and minus 1. Minus 4 and minus 1. How do you handle the minus? What does a minus 1 represent? Hold on, let me think again. Let's go back here. Yeah, 2. 2 divided by 2 is 0, right? So 2 divided is 0. Because we're saying something here, this value, times minus 2 plus 0 equals 2. Now we're going to ask, what is this? What times is minus 1? Okay, so this is minus 1 times this. Okay, so we say minus 1, that's minus 1 divided by minus 2. So minus 1 divided is going to be 0 and with a negative. Right? 0 with a negative. Because 0 times 2 minus 1 equals minus 1. How about we say minus 1 because it's a negative value. So let's minus a minus 2 and then we plus a minus 2 in the front. So it could be 1 with 1. So 1 times minus 2 plus 1. Yeah, so if it's a negative, we just plus 1 and plus 2. Right? So when that happens, we go 1 and 1. So we know this position is 1. And the last position we have is 1. I'm going to say 1 divided by minus 2 is this. So we plus 1 plus this, so this will become 1, and the top is going to be 0. And when it's 0, we end. Ah, that is the trick. I forgot. The trick is the same as base 2, but I forgot that base 2 can be converted using remainder. We can do the same with base minus 2, except when the remainder is negative, we remove minus 2 from it. I mean, it's negative, which can only be, right? Only be negative 1. We remove another minus 2 from it to make it positive, and add 1 to the quotient. Keep doing this until the quotient is 0. So with this, now we can say q equals n, while q, what if q is 0? I can do, we say if n is equal to 0, return this. Otherwise, while qr equals div mod q minus 2. If r smaller than 0, r equal to 1. If this q plus equal 1, and the rest equals this, right? And then we say rest dot append 1, else rest dot append 0. Yeah, there are only two options, either 0 or minus 1. It cannot be even bigger than that, either 0 or minus 1. So if it's 0, then we do this with plus 1, else we do this, and then once we're done, we'll return join rest reversed. Let's see. Yeah, that is the case. I'm stupid, huh? Terrible runtime. That is more like it. Yeah, I don't know, I just suddenly forgot. I forgot how to. So it should be O log n, right? Because you divide by 2, divide by 2, divide by 2. Okay, that shall be it. Yeah, I'll just do this. Same idea. All right, that's it. Hey, I should not have closed. Always have 2 open. But anyway, I have to end today. All right, I'll see you guys tomorrow. Adios.